Hello, thanks for clicking. Welcome to another Knowledge Math production. Today we're going to be talking about inequalities, something that you've learned before and worked with many times. So let's get started and we'll see how this goes. Okay, so an inequality is just a statement that compares two quantities. All right, the quantities being compared use one of the following signs. All of these four signs you should be very familiar with. We have the less than sign, the greater than sign, the less than or equal to sign, the greater than or equal to sign, or this technically is also an inequality, the fact that two numbers are not equal. So if you want to use the not equal to sign, you basically write something like 3 is not equal to 5. Okay, that's your use of the not equal sign. If you forget which one is the greater than and less than sign, my advice is to just use this simple trick. So the simple trick is the less than sign, you can write the word less in it. So this one you can write the word, this sign you can write the word less, this sign you can't, so this is the less than sign. Okay? Now, we're also going to be graphing these, all right, solving and graphing. When you graph, remember the less than and greater than symbols get open circles so that they're not including that value that the circle's on top of, and the less than equal to, greater than or equal to get a closed circle. Okay? All right, meaning that that number is included in the solution. Open circle means it's not. Okay, so let's keep going. Here's the key notes. Here is the biggest, most important thing of them all. This is what I call the golden rule of inequalities. If you multiply or divide both sides of an inequality, let's write both sides of an inequality, by a negative number, you must reverse the direction of the inequality sign. So there's an example down here showing you that. So again, you distribute the 3 in this step. You're not multiplying or dividing both sides by a negative. So the sign stayed the same. And then you combine like terms. It gave you negative 5x. But that's not multiplying or dividing by the same negative on both sides. So the sign stayed the same. You add 6. Adding 6 to both sides doesn't change the sign. But now when you divide both sides by negative 5 down here, here it is. I divided both sides by the same negative. The inequality sign got reversed. It went from a less than sign to a greater than sign. And then if you want to graph that, you'd put negative 10 with an open circle, not including, and then draw your arrow to the right. I want all the numbers that are greater than negative 10. Okay? And finally, what might help some of you is if your variable ends up on the right-hand side, what you can do is flip the entire inequality over so that the arrow kind of points the direction that you're supposed to draw your arrow. So this becomes 6 is greater than or equal to x, means the same thing as x is less than or equal to 6. Okay? I like to say read this from right to left. If you read it backward, it says x is less than or equal to 6. Okay, and then you use a closed circle and draw your arrow to the left. All right, so when reading an inequality, always read from the variable. So this says x is greater than 2. X is greater than 2. All right, so now we'll reverse this. We'll write it like this. Read it from right to left. And now this says P is less than negative 3. And then here we have y is less than or equal to 0. Okay, so again, you want to have your variable on the left. It's easier to read it that way. All right, and then it helps you to be able to graph it also. Okay, graphing an inequality. Remember, you must pay attention to the inequality sign as to whether or not the circle above that number is open or closed, and then draw your arrow. So this says x is greater than 2. 2 is not included, so 2 gets an open circle, and then I want x is greater than 2, so I draw my arrow to the right. P is less than negative 3. So again, it gets an open circle, not including negative 3. It's less than though, so I draw my arrow to the left. Z is greater than or equal to negative 2. So I'm going to put a closed circle on negative 2, and then it's greater than or equal to, so I'm going to draw my arrow to the right. Less than or equal to 0, it's allowed to be equal to, so I get a closed circle. It means 0 is included in my answer. Less than is to the left. Not equal to 1, so I would put an open circle on the 1. Okay, can't be equal to, not allowed. So not allowed to be equal to it gets an open circle. Allowed to be equal to it gets a closed circle. All right, so let's start taking a look. A solution to an inequality is any number that makes the inequality true. This is an important skill, as silly as it looks, okay, because it can help you to solve some of the inequality problems if you're taking that Accuplacer or whatever college entrance exam by using the answers to your advantage. So if x is negative 2, does it make the inequality true? Well, let's take negative 2. We'll substitute it in for x. And we're really kind of asking ourselves a question if that's true. So that's negative 4 minus 4. That's negative 8. This says negative 8 is greater than or equal to negative 12. Yes, it is. Okay, negative 8 is closer to 0 than negative 12. So yes. So that means x equals negative 2 is a solution. All right, let's try with negative 4. We have 2 times negative 4 minus 4. We're asking ourselves the question, is it greater than or equal to negative 12? So negative 8 minus 4, that's negative 12. Is negative 12 greater than or equal to negative 12? Yes, it's equal to it. So x equals negative 4 is a solution. And then if I try negative 6, I bet you can guess what's going to happen now. So negative 16 is greater than or equal to negative 12? No, that's not true. No, so x equals negative 6 is not a solution. All right, that's how we tell if something's a solution to an inequality. Again, you can use that to your advantage if you're trying to figure out what the values of x are that satisfy an inequality using on a multiple choice. Okay, let's solve these and graph these. To solve an inequality, it's exactly like solving equations, except we have to remember that there's this golden rule of inequalities. When I multiply or divide both sides by the same negative, I have to reverse that inequality sign. All right, so for the first one, I'm going to add 4 on both sides. So I just added 4. That doesn't have anything to do with this golden rule. So that means negative 2 plus 4, signs are different. Subtract the numbers, take the sign of the higher number. X is less than 2. So I'd put an open circle on the 2 and draw my arrow to the left. In number 2, I need to divide both sides by negative 3 to get x alone. Now I divided both sides by the same negative. That's the golden rule. So this inequality sign has to get switched around, and 12 divided by negative 3 is negative 4. So I put an open circle on the negative 4, and then I draw it to the left. So 7 is less than or equal to 1/2 x. I'm going to have to multiply by the reciprocal by 2 over 1. Put a 1 underneath the 7. 2 times 7 is 14 over 1. That's 14 is less than or equal to x. So I'm going to switch this around, and I'm going to write x is greater than or equal to 14. Switch the whole thing around. So I'm going to put 14 here on my number line right there because it's a convenient spot. Put a closed circle, and I'm drawing to the right. X is greater than or equal to 14. All right, now number 4, we're going to add 1 on both sides. We have x divided by 4 is greater than 10. So now I got to get rid of divide by 4. To undo that, I'm going to multiply by 4. X is greater than 40, so I'm going to put 40 on my number line here, put an open circle, and draw to the right. Now, the reason I did not switch the inequality sign, I multiplied, but I multiplied both sides by a positive number. This golden rule only applies to multiplying and dividing by negative numbers on both sides. Since the number was positive, I multiplied on both sides. I keep the sign the same. Okay? All right, so now, here's your chance. Don't forget that golden rule. So I'm going to distribute the negative 2. Gives me negative 2x minus 2 is greater than or equal to 6. I'm not going to reverse the inequality sign right now because I only multiplied one side of the inequality by a negative, not both sides, just the left side by -2. So I'm going to keep going, and I'm going to add 2 on both sides. It gives me -2x is greater than or equal to 8. That was addition, has nothing to do with the golden rule. And then I'm going to divide both sides by -2. I get x. I divided both sides by the same negative. That's the golden rule. So this sign gets reversed and becomes less than or equal to -4. So I'm going to put -4 down, put a closed circle, and draw to the left. And then in number 6, we have here, let me just get that out of there so that way I don't confuse myself. We have variables on both sides, but that's okay. So I'm going to subtract 2x on both sides to put all my x's on the same side. It gives me 4x minus 5 and is less than or equal to 7. I'm going to add 5 on both sides. I have 4x is less than or equal to 12. And divide both sides by 4. We have x is less than or equal to 3. So I'm going to put a closed circle. I'll put a 3 there, put a closed circle, and draw to the left. Again, I don't need the golden rule here because I divided both sides by the same positive number. Okay, golden rule only applies to multiplying or dividing by the same negative. All right, and then finally, here's a couple more. So I'm going to try to get v alone. I'm going to add 4 on both sides. So we have -5v is less than -25. Signs are different. Subtract the numbers. Keep the sign of the higher number. Divide both sides by -5. Again, I divided both sides by the same negative. This sign gets reversed. X is great, or v is greater than 5. I'll put 0 down. I'll put 5 down. Put an open circle on the 5 and draw to the right. And then finally, I'm going to distribute the 3 to both of those. 3x plus 6. I'm going to subtract 3x on both sides. I have variables on both sides right now. That's 3x plus 3 less than or equal to 6. Subtract 3. 3x is less than or equal to 3. And divide by 3. X is less than or equal to 1. Again, I divided both sides by the same positive. The sign stays the same direction. So I have 0, I have 1. I have a closed circle on 1. And I draw to the, I draw to the left, not to the right. Draw to the left. X is less than or equal to 1. And that's it. Okay, and as always, thanks for clicking.